times x plus 3. And then once you have it down to just a single log on one side and no logs on another, how do you solve that? What do you have to do? No, logging both sides is if you have like a variable in your exponent that you're trying to get out. We don't have an exponent with a variable.
Wait, so you shouldn't multiply through there?
You can, like, do this.
Yeah, like I swear.
That's fine. Same thing. But then the question is, how do you get this into something that's solvable?
Divide them.
Yes. Good job, Alyssa. You translate it. Your base of 10 raised to the first power equals x squared plus 3x, and then you solve this quadratic. So subtract your 10 over. Factor. Tee it up. And check for extraneous. So are either of them not going to work? Because you can't take the log of a negative. So if you tried to plug in -5, you'd have a problem. Now mentally you should just know you can't take a log of a negative, so we're going to reject that one. If you typed it into your calculator to check it and you tried doing log of -5 plus log of -5 plus 3, it will not equal 1. It will give you an error. So your only answer is 2. With logs on both sides, I would argue that this usually goes a little bit better. You still condense addition into multiplication again. I wish that was subtraction, because just to review, if it was subtraction, it condenses into division. So this will be x times x minus 4. So single log on the left, single log on the right, what can you do? Cross them out. Right, exactly. So that way is usually a little bit easier, because even if kids don't know, that's like their guess to do that. So x squared minus 4x equals 12. Again, solve the quadratic. And do either of those give you a problem?
Wasn't it -2?
-2. Cross that out. Good. So solving log equations, good. And those are your two different types. Finding all rational roots. So be sure to include the rational root theorem. So this has been a while. The rational root theorem lists all of our possible rational roots. Where do those come from? So these are your possibilities. What'd you say, Ryan? P's and Q's. Connor said first and last. Your P's are your factors of your last term, and your Q's are your factors of your first term. So P's over Q's, all the combinations of P, 1 in 65, 2 doesn't go in, 3 doesn't go in, 5 goes in, 13 times? That's it, right? 1, 65, 5, and 13 are your only factors of 65. Your factors of 2 are just 1 and 2. So when this is a little, there's a few more combinations here, because we've got options in both the numerator and the denominator. We could do 1 over 1, which is just 1, or 1 over 2, which is a half. You could do 65 over 1, which is 65, or 65 over 2, which I'm just going to leave as an ugly fraction. 5 over 1 is just 5, 5 over 2. 13 over 1 is 13, 13 over 2, and all of these plus or minus. So we really have 1, 2, 3, 4, 5, 6, 7, 8, 16 when you count the positive versions and the negative versions. 16 possibilities. So if you have rational roots, they're definitely on this list. Now it comes time for finding which one do we start with. Right? Yeah. Right, so at maximum, only 4 of these of the 16 are going to work. And that doesn't even mean all 4 of them. That could just mean 2 of them work and the other 2 roots are imaginary. Or the other 2 roots are irrational. These are just your rational ones. So how do you decide? I would cheat on your calculator. Correct. Just to get something to start with. So type in your function, look at it, rather than blindly guessing, which could take you a very long time, and you don't have that long. I'll fix that for you. How's that? That better? Zoom 6. Right, your window might need some work. So I'm showing negative 10 to 10 now. I at least got something. I definitely don't have a good vision of the entire graph. That first one looks like a fraction, which I don't love. 1, 2, 3, 4. This one looks like 5 though. Yes, and 5 is on our list, positive 5, so that makes sense. So I'm going to start my division, and I'm going to do synthetic with 5. So if I go to pull out a 5 from synthetic, I've got a 2x to the 4th, 1x cubed, negative 35, negative 113, and 65. So we have to review synthetic right now. How does it always start? Pull down the 2. Then what? 5 times 2 is 10. Then what? Add, you get 11. And repeat. 5 times 11, 55. Add, you get 20. 5 times 20, 100. Add, you get negative 13. And then this just confirms that it worked. And what you've essentially done is you've factored out, if the root was 5, what did you really factor out? X minus 5. And it was a 4th degree polynomial, so now this is a third. So 2x cubed plus 11x squared plus 20x minus 13. So we really partially factored this. If we're lucky, what's left, the 4 terms, would be groupable, so we could be done with the whole synthetic division process. Unfortunately, it's not. Because I'd take out an x squared, I'd be left with 2x plus 11, and I can't take out anything, so I'm left with 20x minus 13. That doesn't match. So I just have to cheat for my calculator and look for one more. I could open up my window and see if there's another whole number, but you don't. We should probably practice synthetic with a fraction. So if I look for that 0, left bound, right bound, it's 0.5. So that's my positive 1/2, which is on my list. So picking up with where I left off, I'm going to synthetically divide out a 1/2. Oops. So 2, 11, 20, and negative 13. Bring down my 2. A half times 2 is 1. Add them, you get 12. Half of 12 is 6. Add them, you get 26. Half of 26 is 13. Add them, you get 0. So again, 0 is what we want. So here's a good question. If I synthetically divided out a 1/2, what's the factor? So I still have an x minus 5. What factor does a root of 1/2 create? You can't, when you do a factor, you don't have a fraction in it. Good, Allie. So if the root is 1/2, the factor, and then subtract 1, was 2x minus 1. That's the factor that created 1/2. And then that was a cubic that we did synthetic division on. So now this is a square. Times this. Because it wants us to find all rational. I'm like going kind of above and beyond what they're asking, just because there are a lot of variations of how they can test all these skills. So I was just like factoring it out completely to find all the rational roots. Well, you got to look for all the rational roots. So, well, I'm gonna, when you're done factoring and it's factored completely, you're done. So once you get down to a quadratic, you're definitely done with the synthetic division version of factoring, because you can factor any quadratic just by hand. So I would pull a 2 out of this to shrink up those numbers. And constants usually go up front. And that would leave x squared plus 6x plus 13. Is that factorable? No. If it's not factorable, they're not going to be rational roots. They'll either be 2 irrational roots or they'll be 2 imaginary roots. You'd have to do the quadratic formula to figure that out. But this just asks for all the rational roots. So your only rational roots are 5 and 1/2. Right. Because when things are factorable, their roots will be rational. If they're not factorable, they're either irrational, because it's an ugly number that comes from square root of 15 in the quadratic formula, or they're imaginary because it comes from like the square root of negative 15. So and this said find all the rational roots. We have 2 of them. If it said find all of the roots, we'd still have 2 more to find, which are going to come from the quadratic formula. Does that make sense? So I'll just quickly do the quadratic formula just so we can get all 4. Negative b plus or minus the square root. B squared is 36 minus 4ac all over 2a. 36 minus 4 times 13. That's a negative number, isn't it? Negative 16. Negative 6 plus or minus the square root of negative 16 over 2. What's the square root of negative 16? 4i. And when you divide both of those terms by 2, because you can, you get negative 3 plus or minus 2i. So these remaining 2 roots, are they irrational or imaginary? Right, imaginary. So there are all 4 roots. Again, I went above and beyond what the question asked for. But pay attention to details like showing all your work and including, just to test, the methodology of the rational root theorem and synthetic division. Good? Oh, man. So B is the same thing. I'm just going to skip that one. It's a different problem, but same exact concepts that we just reviewed. Sketching rational graphs. This was not a great chapter. So this was knowing and we'll review, where your vertical asymptotes come from, where your horizontal asymptotes come from, where your x-intercepts come from, where your y-intercepts come from. And holes. Okay, so let me review your steps. Step 1 is going to be factor anything and everything. So in number 1, that's going to be the denominator. X plus 4x minus 5. Factor everything and cancel if possible. Anything cancel here? No. Okay. Step 2, or in the next few steps can happen in any order, would be, let's say, x-intercepts. The x-intercepts come from zeros of your numerator. So what are those? What x values will be a zero of your numerator only? 0, right? So your x-intercept is at x equals 0. That's the only one. Your y-intercepts come from plugging in an x of 0. So if I were to plug in an x of 0, I would get 3 times 0 squared over 0 plus 4, 0 minus 5. What would that all simplify to? The numerator would be 0 over the denominator would be negative 20, and 0 over anything is 0. So your y-intercept is also 0. Then you want to find your vertical asymptotes, which come from, who remembers?
Oh, isn't it something like the f of x is 0?
No. The denominator. Because zeros of the denominator make it undefined. And when things are undefined, there's usually an asymptote there. So your vertical asymptotes are at x equals 5 and x equals, what else will zero out our denominator? Negative 4. Then you have your horizontal or your slant. It depends. And this is based on the degree rules, comparing the degree of the numerator.
Oh, yeah.
Degree of numerator versus degree of the denominator. So the 3 scenarios are small over big, big over small, same over same. So if it's small over big, you're at y equals 0. If it's same over same, you're at y equals, you remember this one?
Oh, you divide them, right?
Coefficients, you divide the coefficients. So it would be coefficient of the top over the coefficient of the bottom. So if that was like 8 over 4, that would just be y equals 2. And then if it's big over small, you have no horizontal asymptote, but you have a slant. And how do you find the slant? Long division, right. So those are the 4 main features, and then what causes a hole? Right, if when you factor something cancels, like if you factored in an x minus 5 canceled with an x minus 5, you would have a hole at 5 something, right? And then to figure out the y coordinate, you would just plug 5 in to the simplified version. So hopefully by the time we do the 2 of these, we'll see a lot of examples of this. So we did x-intercept, we did y-intercept, we did vertical asymptotes. The horizontal asymptote. When you look at, and it's probably easiest to look at the original, the degree of the numerator is what? 2. The degree of the denominator is 2. So it's same over same. So your leading coefficient is what on top? 3 over what on the bottom? 1. So your horizontal asymptote is y equals 3 over 1, which is just 3. And if you have a horizontal, you don't have a slant. So there's no long division you would need to do here. And did anything cancel? Because we already kind of crossed the whole. No, nothing canceled, so we have no holes. So when you set this up, my recommendation is get your asymptotes in there first. So your vertical one's at 5. And -4. Your horizontal one's at 3. I'm going to scale that differently just because I'm working in tight space here. So how many, bad word, but I'm going to use it, how many quadrants did those asymptotes create? Quadrants, because quadrants really means 4, and there's not 4 anymore. 6. We have the top left, which we just see a little sliver of, the bottom left. So your graph will either be in one of those, top or bottom, has to be in one or the other. And then in the middle, you've got a top and a bottom. You could kind of be in both of those. You might just be in the top, you might just be in the bottom, or you might thread through both. That remains to be seen in the middle. And Allie? This 3? It was same over same. Did you follow that? And so then your coefficient of the x squared, 3 and 1. Yeah. And then on the outer 2 quadrants, you've got either the top or the bottom. You'll never be in both of those. Okay? These outer ones kind of create corners. So it'll either be like cornered, look up at the board. It'll either be cornered up here or cornered down here, one or the other. Same thing on the outsides, and we kind of have to see what goes on in the middle. So those I've graphed. My y-intercept is 0 and my x-intercept is 0. Here's a crazy idea. To figure out which corner it is on the outside, just plug in 1, 2, 3, 4, 5, 6 and see, is it something greater than 3, which would put it up here, or is it something less than 3? So if I plugged in 6, and you have your calculator, so why not? 3 times 6 squared up top, divided by 6 plus 4 is 10, and 6 minus 5 is 1. 10 times 1 is 10, so just divide it by 10. 10.8. So is it greater than 3 or less than 3? I plugged in 6, I got 10.8. It's up here somewhere. So that handles that entire end. Right? It would have been cornered down here. I plugged in 6 because it's just to the right of that asymptote. So that covers that outside. If I want to cover this outside, I would plug in, here's -1, -2, -3, -4, maybe -5. Decide if it's above 3 or below 3. So if I plug in -5, I'm going to get 75 over -1 times -10, 10. I'm going to get 7.5. Sorry. And you could plug in -5 to the function on your calculator. And it's, again, it's above 3. So is it cornered up here or down here? Top left. Now, traditionally how vertical asymptotes work is that if on one side it goes towards positive infinity, then on the other side it goes towards negative infinity. Except for when what? When do they both go towards positive infinity? If that asymptote at -4 came from a factor that was squared. Does that make sense? Yes, no?
Yeah.
Okay. If your degree, so do you see how your asymptote at -4 came from this factor? Okay. If that factor has a degree of 1 or 3 or 5, it's going to have opposite behavior on either side. But if it's if this ever had factored into x plus 4 squared, and that, factor where the asymptote came from had a degree of 2 on it, then they would both go towards positive infinity. Like, look at the difference. If I just do 1 over x minus 3, where's my asymptote going to be? Where would it be? 3. So if I graph that, you'll see it at 3, because it'll shoot down on one side and shoot up on the other. But if I changed that to 1 over x minus 3 and I squared that, now when it approaches that asymptote, it's going to shoot up, and it's going to shoot up on the other side too, because it was an even degree. It'll be opposite again. 1 up, 1 down. Yeah. It's kind of like the same, it's the same logic as like odd degree polynomials start low and high, versus even degree ones do the same thing on both ends. It's the same idea happening there with the degree. Again, worst case scenario, plug in -3 and see what happens. But because this one goes up, this one's likely to come down. And because this one goes up, this one goes down. Yes? And we have to catch that x-intercept and that y-intercept, so that pretty much tells us it's just a parabola opening down. Waiting. Now, keep in mind, unlike on this test, on your midterm, you have your calculator. You still are going to need to outline what is the x-intercept, what is the y-intercept, what is the vertical asymptotes, horizontal asymptotes, where are your holes, what's your slant asymptote if that comes up. So you still need to know how to do all that and show your work for all of that. But at the end of the day, if you want to check yourself, 3x squared divided by x squared minus 2x, minus regular x, minus 20, just graph it and you'll see really what we just did. You love that, JR? Satisfying, right? Okie doke. This is easy. These are E equations, but they're kind of quadratic as well. Do you see the quadratic structure? You don't? Yeah. True. Well, if you know where your vertical asymptotes are, and you know where your x and y intercepts are, based on... Negative 10 to 10 should have worked. Hit zoom 6 again. You might have typed, that's the other thing, that's what's dangerous about the calculators. You type the thing in wrong, just one little thing, and you're just totally thrown off. You don't even know what to do. That would be lovely, but that doesn't happen all the time. Help her out. Why is hers not showing her the right answer? Right, your calculator knows order of operations. It's doing division, so it's just dividing this by this, and then it's subtracting those things at the end. You have to divide by the entire polynomial, so you need to put parentheses around the entire bottom. Yep. Okay, so, you know how a quadratic, who said they didn't see the quadratic? Okay, so something squared minus something plane plus 5. So when you factor this, The only way to make e to the 2x is e to the x and e to the x. And then the only way to make, well, there's a couple ways to make 5, but you have to make positive 5, and on the outer and inner negative 6. What would those two numbers be? Good. And then just like any other quadratic, you tee it up. On this one, add 1 to both sides. On this one, add 5 to both sides. And then we're going to talk, how do you solve an e to the x problem? ln, right?
ln, natural log.
If it was 5 to the x, you would take log base 5 of both sides. This we're doing log base e, which is ln. So the ln e cancels, and x equals the natural log of 1, which that's a property.
That's nothing.
A log of 1 is always 0. And on this one, ln will give you x equals natural log of 5, which is going to be some crazy decimal. E to the x times e to the x. When you multiply common bases, you add the exponents, and x plus x is 2x. I'm just going to write this. If I did 5 to the 2x minus 6 times 5 to the x plus 5 equals 0, your bases are 5 to the x and 5 to the x. Follow that? Because that's just multiplying common bases. You keep the base of 5, add the exponents. We'd still have minus 5 minus 1. I'm showing you this more for the sake of solving an exponential equation without an ln. So if I added 5 over, that's pretty easy. What does x equal? 1. This one I think will be a little bit tougher. Because 5 to the, oh no it won't. Because what does x equal? 0. But what if you had 5 to the x equals 20? What do you do to both sides to solve that? This is where we talked about the differences between, right, Mrs. Ziggeist's kids from last year definitely would take log base 5 on both sides. Yes? Right, and that's fine. If they took log base 5 on both sides, they would get x equals log base 5 of 20. That's correct. I believe Mr. and Mrs. Hill's kids just did log of both sides. So you did log, and then brought your x out in front. And then you divided the log 5 over, and you got x equals log of 20 divided by the log of 5, which is also the right answer, because those two are the same based on the change of base formula, right? Change of base says that you can do this with log of 20 divided by log of 5. Good? Whew. So we will, how about this? For homework, just do 3B, 4B, and 2B. Just those 3. See what questions come up, and then we have another review sheet tomorrow. On the notes, just finish the notes examples that we didn't do. We didn't do 3 of them. Maybe you did. Okay. Yeah. It's kind of like a game.
Wait, what are the review sheets? That is for you?
Hold on, let me cut this up for you.
Okay.
It's a game.
Wait, so we don't have it. It's not like a 2 right?